Hello, this part of adding a custom logic to a runtime. We're gonna learn more about the storage, some basic the structure of the storage, like a map, a storage items, and also some key method of the storage. On the other hand, we also learn about the architecture, also multi levels of storage layers in Substrate. And right here, I'm gonna reuse a slide of South Tabrizi, a former core engineer of Parity. The Substrate storage has these abstractions, and we break it down to 4 different layers. The first one is gonna be the runtime storage API, and then overlay transets, Merkle drive, and then key value database. So the runtime storage API can be called to the SPIO that allow you to can write to store it with a given key value. So in the palette, you remember the palette storage macro. So when you define storage items using the common data type, like storage value, storage map, or storage double map, that you can allow to write down to the key values database right here. But before going to that, the underlying layers of the key value database, you have to go over the overlay genset. And what is the overlay genset? So the overlay genset is the state changes to the underlying database. So before you go into the key value database, you should have another layer that overlay all the changes that are committed once per block, and 2 type changes. We have the respective changes and what may happen, and committed changes what will happen. So that means whenever an error that happened on this overlay genset, and whenever an error told it doesn't revert back all the state changes and doesn't write to the key value database underlying, that why you need the overlay genset stand in the between, because you don't want any operations that call it to the dispatchable functions gonna write to the database directly, but you also want an overlay layer that act as the middleman for those state changes. Polkadot is a hash database, and it's from the great parity tag try. You can also see it on GitHub. It's a data structure on top of the key value database, and arbitrary key and value length, node and R branches or leaf. So in blockchain, the Merkle tree is a very common data structure that record all the state changes and in an efficient way. So whenever you want to check if the state at the historical block is valid, then you just check to the Merkle try with the Merkle proof, and then see that if that state is valid to our the historical record of the blockchain. So the key value database of Substrate is usually RockDB, but now it's already used the Parity DB instead of the RockDB. So to talk about it, the Parity DB is a database designed by the Parity technology company, but in a more efficient way for the blockchain, simply speaking, and because there's some kind of overhead in the RockDB that doesn't very good for the scalability of the blockchain, and also the performance of writing to this RockDB key value database. One thing must be noticed that you should only store consensus critical data in your runtime storage. Not everything that you should store in your runtime data, because storing data on the runtime is different from storing data in the Web2 server. So in the Web2 server, you can store anything, basically anything, but on the blockchain, block space is sometimes expensive, so you have to use it meticulously, and also take into any considerations for the data, for any bytes you store into your runtime storage. The first scenario would be a decentralized block, so the runtime should be able to come to the consensus about the content in the blog post. So you can store the text on the IPFS, or then you store the IPFS hash to your runtime storage. Do not store the text of the post in the storage, because imagine if you have a post up to 1,000 words, that means it's gonna be more than 1,000 bytes, and then when you store in your runtime storage, that would be a nightmare. And depend on how many fields that you're gonna have inside the struct. But if you have multiple fields, that would be best if you can use a struct. But if not, consider using a storage value instead of a struct. Whenever you do an upgrade on at runtime, you have to do migrations. So the final try part of your storage record is defined by the 2x128 hash of the module name, and also 2x128 hash of the storage name, and then the hashers the peak hashes. It can be like black 128 or like 2x 128 hash over like the key of the record. So there's two common hashing algorithm in Substrate. The first one going to be a black 2. The second one will be the 2x. So what are these two, and what are the difference between these two? So the black 2 128 concat generate a cryptographically secure hash of key that can be verified and used to access data on the Substrate runtime state. 2x64 concat generate a fast non-cryptographic hash of key that are ideal for low latency use cases. And remember when we talk about the runtime storage API, SPIO, that allow you to write to the storage with the key value. And right here, we have the SPIO storage in this grade. And this allow you, it provide you some set method that allow you to write to the overlay genset. If I want to write, I'm gonna like call this set method, and as you can see, like it's gonna receive the key and the value. You can also define the underlying implementation of that SPIO set storage set method in the Polkadot SDK, and as recommended, like whenever you want to learn something about Polkadot, just open the Polkadot SDK and everything will be there. So right here we have the overlay changes. So the overlay changes, as I mentioned, is like the set of changes that are overlaid onto the backend, and it allows changes to be modified using the nestable transactions. Before like making any changes, state changes applied to the Polkadot, you have to pass to the overlay changes and make sure like there's no error throws. So in the overlay changes, here's like the structure of the overlay changes. But in this video, I think we shouldn't care about this. And inside the overlay changes, there's a method called a set storage. So this set storage method is set a new value for the specific key and can be rollback or committed when called inside a transactions. Whenever there's any error throw, set storage gonna like rollback and not like commit to the Polkadot. There are a few different places that this set storage method is used. For example, here the SPIO storage is used to set the well-known keys of the index in the frame system palette. This is when the changes is built and you want to set the index of the transactions. You may wonder like what is the well-known key. So the well-known key is the list of all well-known keys and prefixes in the storage. So here we can get to some common well-known keys. For example, like the WAMS code of the runtime. This is like one of the most important well-known key that you when you work with Substrate you might know. It's gonna be like the SPIO storage, and then like set with the well-known key. Code, and then it's gonna set the code with the vector U8. And right here, the vector U8 is the WAMS blob, the web assembly blob of the runtime, and that is how the SPIO storage set is used in the runtime upgrade. And now we go back to the example palette that we just had in the very first video, and now we're gonna play with like some of the storage items and how to write to them and how to like read the data from those storage items. So right here, because we already like play with the storage map and the storage value, so I'm gonna like change it to maybe like call it like as double key balances. So this double key balances is basically like have two keys from the two account instead of like only one. I guess like instead of like call it a double key balance, the better way that we can call it maybe a balance timestamp total balance, total account transfer, total direct transfer. So this total direct transfer palette storage gonna do that we basically gonna store the transfer record of the sender and the destination with the balance. So in that way, like we can like accumulate the transfer record value, the each in total. Accumulate in total each transfer record value of the sender and destination with the balance. And to do that, I need to use the storage double map. And with the storage double map, you have to provide the two key without a prefix. Don't have to care about that. Then you can like provide like black to 128 or 102 to 125 depending on the key, but in my case we don't need the 225, but only a black to 128 is enough. And then you have the account ID, which is the sender, and then you have black to 28. This one is the destination or recipient, whatever you call. Then you can, then the last one gonna be the value. So the value of the storage tuple map gonna be the balance with the value query, similar to the above. And then we have our storage structure. The another way that we can also do that is, let's say this is storage direct transfer. Maybe let's call it storage direct transfer and storage direct transfer, because we're gonna use the storage tuple map, storage end map, sorry. And in the storage end map, we have to provide the key here, the key, the number of key, and this must be the end map key, storage end map key. The first one of the storage end map key, it must be the hashers and the key type. So our hashers are going to be the black 128, which is our sender, and then we provide again for the destination. Here, sender, and then the destination. And now we want to write to the storage. So in our code, when you call a mint and save, you want to write to those storage. So let's call it total direct transfer. And what we want, we also try mutate. But we have to specify the two key. The first key gonna be the sender, gonna be the minter. No, it should be transfer. Sorry, not mint. The transfer. The first one gonna be the sender, and then the destination. Then we have the lambda function here that get the balance. With the balance, we gonna increase. We're gonna saturating add. Or maybe they call it check add. With what is the value that we're gonna add it, and it must be the increase value. Increase value, and if it's not, if it doesn't work, then we have to throw arithmetic error overflow, and right here we're gonna return the dispatch result with the OK. Let's see if our code compile. Oh, it should be check out. Sloppy. To specify generate type. Then it's gonna work. Then we also can call it. This is total and total direct transfer. And with the end key, with the end storage map, we only have to specify one tuple. Is like when you go check, and it's gonna work. But this one is wrong. And this is how you write to the storage tuple map and the storage end key. Checking. Okay, now it's work. Maybe that we can provide a few other method, like let's call it common functions. So we want to read, these are some common functions that we want to read from. Let's say the first one going to be the balance, maybe the total issuance. Compile. Then in our total issuance, we can get total issuance. We can get just basically get, because it doesn't have any value. It's just a scalar, and what we return the balance. And then we can also have another method called balance of, because we want to get the balance of the user. And here we are going to provide the account, which like the account ID, then the balances with the account. Then we can get the balance of the account. And we can also like provide another method called balance record. No, total direct transfer. Then we have like the sender and the destination, that you can use total direct transfer to get the sender and then destination. Also similar to that method, we're gonna have like the end total direct transfer, and in this end direct total transfer, we so let's just get the two key, sender and destination. And with Substrate, instead of like writing those methods on your own, you can also use the features, the macro called getter from the palette, right? And this you're gonna specify the total issuance at one of the method. Issuance. Balance of. Then total direct transfer. And as you can see, when you define that, it's gonna hold all the definitions for total issuance already they declare. The magic of this macro, like is from the storage items, it's gonna generate the method that to get the information from the storage value and also like the storage items. So right here, like this method now is tone error because like you already like have those methods generated. So the way that you can do is like just simply remove those, and your code gonna work. When you run like cargo check, you're gonna see like it's gonna like compile successfully. We go back here, and there are also a few other methods that I think is quite interesting for you to use. The first one is gonna be like the iter refix. So when you go to the storage, maybe the storage double map, there's gonna be a method called like iter refix. So the iter refix method allow you to iterate over iterate over the double map, but like only they specify the first the refix. For example, like in our case, when we go back to our code, and let's say like if I want to iterate here, like total direct transfer for the sender. If I want to iterate over the total direct transfer for only the sender, I can like specify only the sender as the key, but here it must be the iter prefix, iter prefix value. Then you have to specify the sender, and then like it's gonna return the iterable. That as I remember that you can call this method of the refix iterable. This one gonna have a strand method. So refix last row key. So from this iterable, what you can do is like you can enumerate, and then you loop it over. You simply like loop it over this iterable, and then like you can accumulate here a total transfer for the sender equal to the balance 0, and total transfer for sender plus here is saturating it, and we want to return total transfer for sender. We add with the value of the key. It's gonna return the index. We skip the index and we only get the balance. Let's call it total transfer for sender. And then you have like the successful method. When you run like compile, it's gonna return successful. And that's also the end of today's video. Hope like you already learned about some advanced concept of the substrate storage, like different layers of the substrate storage or the abstractions, and also like some common data type like storage double map, storage and map, and also like how to like iterate over the storage items like storage map and storage double map. And I hope you like it, and see you in the next video.